Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome back in lecture 4. Students, in lecture number 3, basically we start the two-way slab analysis and design, and we reached basically to torsional reinforcement. Okay, we stopped the calculation on torsional reinforcement. Let's see, and we also did the calculation in Excel sheet, that how, if that sheet is available, Excel sheet, how you can easily search your CA and CB values. Okay, so then the procedure will be simple. Okay, because in two-way slab, movement coefficient method, basically the choosing of these coefficients is a little bit tricky task. Okay, now let's proceed further. We have a torsional reinforcement. Okay, and a torsional reinforcement is that reinforcement which is provided at the corner points of the slab. Clear? Let me show you this one. Okay, for example, I have a drawing. Okay, this is the drawing. Okay, so in a two-way slab system, basically at the corner points where the corners are simply supported, there is no column or beams. So at those corners, basically we provide what? We provide torsional reinforcement. There is a little bit torsional effect, and due to that, to prevent that effect, basically the slab which is right here at this corner, similarly at this corner, okay, and this corner, this one, okay, similarly this one, not this one, okay, because there is beam, and there is this one, and this one. We have to provide torsional reinforcement. Okay, now that basically here the slab tending to rotate in this direction from the walls. Okay, so that is a torsional effect. Okay, so to offset that effect, we provide torsional reinforcement at the corners. Remember that torsional reinforcement may be provided in two patterns. One pattern is this one. Okay, we provide extra bars, the top and bottom as well. Okay, and this in this pattern. This arrangement, top bottom bars. Okay, and similarly at the lower portion or the lower bottom portion, we have to provide same in similar manner torsional reinforcement in both ways, top and bottom. Okay, like let me show you in cross section. Here is a torsional reinforcement, and that is the top bars. Okay, there is a top bars, and at the lower portion as well. Okay, at the lower portion, at the bottom of the slab. Okay, and similarly, one pattern of torsional reinforcement is that we provide this kind of reinforcement in this pattern. Clear? In diagonal form. Okay, in diagonal form, both at the top portion and the bottom portion of the slab. The distance for which this reinforcement is provided is basically, this is the shorter direction, I think so, this is the longer direction. So LB divided by 5, and similarly in that direction, the maximum direction, LB by 5, okay, LB by 5. Clear? So here you see the reinforcement that is provided here. You see LB by 5, that is 3.8 feet from face of the support. You have to provide number 4 at the rate of 11 in center to center. I will explain this point. Okay. So now one important thing which I want to share with you, and this is very important point. Okay. So most of the time students are confused. Like in this slab system which I'm covering here, is, you can say this is symmetrical system. All the slabs are uniform. Okay, but sometimes almost many students mail me regarding this question that, sir, please do some example that in that we are facing different slab systems, like one-way, two-way combination system. Okay, and I already recorded a video on it. Okay, that if you're facing such type of slab system in which there is non-uniform spacing, non-uniform panels, how you can do? Please search it on my channel. You can find that video, non-uniform spacing, how you can handle that problem. Okay, this is available on my into my playlist as well as on my channel. Okay, but here I want to share with you that look to this problem, like you see here in this example. This one, you see this panel and this panel is uniform, but this veranda is non-uniform. You see, this is 1612, but this is 9 feet, and the length is different. Now you see there is two-way and one-way slab combination. Okay, so many times you face, whenever you are designing a house system, you have rooms. Similarly, you have kitchens and bathrooms, and you have lounges. Okay, so different panel system. In that system, I recorded a video on it. Okay, a lecture on it available on my channel. Okay, please watch that. How to cope with that problem. But here you see that we have two-way slab system and one-way slab system. Okay, so in this case, you have to how to calculate the thickness of slab. You have to use the two-way slab system thumb rule formula as we did in our present example, and then you have to calculate, because you see the two-way slab system is continuous to the one-way slab system. So that's why we have to use to find the slab thickness, we have to use the one-way continuous slab system formula as well, that is L by 20. Okay, so you have to choose the maximum value, and the maximum value is, you see, 5 inch. Remember, this is the way that how you can deal with it. Okay, and this problem is very common. Okay, and many students face this problem. So I therefore share this very useful information with you people, that how you can cope this. Okay, when you facing non-uniform spacing. Clear? And one thing which is very important. Okay, and here you see that there is this is your longer direction, this is your shorter, this is your longer, this is your shorter. Okay, and then you will design this as a two-way slab system, but this slab system is a one-way slab system. Remember, this is important. Clear? So let us proceed. Okay, I already did this calculation. Okay, remember that the panel C is basically a square panel. You see, 19. So that's why MA negative and MB negative movement will be same, and MA positive and MB positive movement will be same. Remember, this point is very important, that you see when the panels are same, the movements are same. Remember, both in shorter direction as well as in longer direction. The negative one and the positive, the negative one, both in shorter and longer direction. And similarly, in positive direction, basically in both in short and longer way, longer and shorter way, they are same. But the important information which I see here, that the positive movement is lesser than the negative movement. This is interesting. Okay, the negative movement is maximum. Okay, this is important. Now we are now proceeding towards the design. Remember, here I am presenting you the most simplest way that how you can design FUO movements. Okay, so one of the most important formula which I got from some notes, I did not see this formula in any books. I did not see this proof of this formula, but this formula I found in notes, and this is very useful formula. Remember, this is very easy formula. It basically saves a lot of time of students when they are dealing with the calculation of steel, because you have to use trial and error method, head and trial method, and they are time consuming. Okay, they are sometimes inconsistent. This formula is very simple. It can be used for all kind of problems, beams and one-way slab system, two-way slab system. Remember, what we have this formula, you see I already explained this formula in one of my lectures available on my YouTube channels, frame analysis. Okay, FC prime Fy, D minus this is effective depth, and Mu, remember this is this kip inch. Okay, so you need to convert the movements into kip inch. Okay, and all things are fixed. B is in inches, D is in inches. So D is what? This is the effective width. This is the total width minus total depth minus clear cover. Okay, you have to provide 1 inch clear cover because you have, remember this is your cross section of concrete, and let's say this is your main bar, and there you have your top bar. Okay, so remember your D effective depth is from this one. Okay, this one, and remember that in two-way slab system we have bars taking load in both directions. Remember, okay, so that is the effective depth. Remember, now the effective depth is 4.1 inches. The most easiest way is that you need to calculate your AS minimum. This is 0.018 times of gross area of concrete, that is 5.5 into 12, because we are designing for a 12-inch strip of the slab. So that's why we have this one value of AS minimum. Now you need to calculate your AS maximum, 0.0214 AG, that is your gross area, and you got this is the maximum reinforcement. Now the steel area which you are providing, basically rho provided, it should be greater than rho max. Okay, it should be greater than rho max. This is ductility check, and it should be less than, sorry, it should be greater than rho minimum. Sorry, this is rho minimum and this is rho max. Clear? This is ductility check. So that's why we calculate, or you can say that your AS max, your AS provided should be greater than AS minimum. Clear? And should be less than AS max. Clear? So this is the approach which ACI basically explained for ductility control. Remember, to prevent brittle failure. Okay, so you have to find out the maximum spacing. This is 11 inch. You don't need to exceed your spacing more than 11 inch. Okay, now the next tabular calculation you see here, this is very important calculation. Remember, okay, we basically summarize the whole calculation in one table. We have panel and panel movements. We have steel required, we have provided steel. Okay, this is that amount of steel which we provided, means this is provided, this one. And this is for each strip. Remember, I will explain what is middle strip and what is each strip. Okay, so in panel A, basically as we calculated, our MA negative is 0, but remember you not need to consider it as 0. You have to take it 1/3 of MA positive. This MA positive movement, this 26.67 will be divided by 3. The movement which you got will be right here. Okay, so 26.6 divided by 3. Okay, this movement will be right here. Okay, MB negative, MA positive, MB positive. We calculate all these movements as previously. Now, remember, this is the steel which is required for these movements. Okay, and from where we calculate these steels, remember the calculation is so simple. You have to just insert these movements into this formula. Okay, into this formula you got these area of steels. Okay, just plug 66.76 here. Okay, D is 5.5 and FC prime is 4, Fy is 60, D is 12. Do the calculation, you got this one, 0.288. Similarly, plug this 26 here instead of Mu, you got this 0.11. But very important information that 0.11 is less than 0 AS minimum. So that's why we can't use this one. We have to reject that. Clear? and similarly 31.662. Plug here, you got the answer, and the answer will be 0.133. Now this is the required area of steel which is needed for this kind of movement, to control this kind of movement. Now we need to check this movement, that whether it passes this criteria, that this is my area of steel provided, whether it is greater than S minimum or whether it is less than S max. Okay, so this ductility check should be confirmed, remember. Now, and one other check is that your maximum spacing. You have to check your maximum spacing as well. Okay, so if your A is greater than A is minimum, okay, A is, you see here 0.288, okay, 0.288. Now you find out your spacing, clear? So the formula for spacing is simple. S can be calculated as area of bar divided by area of steel times 12. Okay, this will give you the spacing. Now the area bar, that is, we are using number 4 bars, so you have to insert the exact amount of value, 0.19 something, whatever the values, 4 to 5 values you have to write down here. And AS is your 0.288, clear, and multiply by 12. Remember, if you are needed to calculate the area of bar of, this is a very new formula which I want to share with you, okay? This is very a new formula. You are using number 4. So 4 divided by 9 and square it. This will give you the area of number 4 bars. If you have a calculator right in your hand, you just need to calculate 4 divided by 9, okay, and square it. You got the area of number 4 bar, that is 0.1975 and 3 square inches. This is the simple formula you must remember. If you are using tables, so just remove your tables and use this formula. Number, whatever the number 6, number 8, number 9, number 10, just write down here number of bar, that is 10 divided by 9 and whole square. It will give you the area of that number of bar. Okay, so this is the very most simple formula. So you calculate your spacing from this formula and you got that this is number 8. Please let me check it. 0.19753 times 12 equals to, divided by 0.28. I got the value at 0.46. Okay. Once I basically I did the calculation for the spacing, I got the value at 8.46. This is equal to 8.46 center to center, inches center to center. So that's why I'm using here what? 8 inch, conservative approach, 8 inch center to center. So that's why you see here number 4 at the rate of 8 inch center to center. But remember, as the required spacing is 8.46, now you decrease the spacing, so that's why your provided steel will be greater than that 0.228. Now you need to calculate that area of steel provided. Okay, so that's why area of steel provided will be right now area bar divided by now your spacing. Remember, and this is your 12. So this is the area of steel provided. Okay, this is the area of steel provided. Let me calculate it. Area bar is 0.1975 something times 12 equals, divided by spacing, that is 8 inch now. Okay, so it will give me 0.29. So this is now my provided steel. Remember, this it has an effect. Okay, 0.29 and 0.28. Okay, so this is my right now my A is provided. So So A is provided, basically you see here S minimum is this one. So A is provided is maximum than this one, but less than A is max, that is 1.156. So here I am okay. Okay, my check is okay. Do the same calculation for all of the values. Remember here 0.22 is a confusing one. Remember that if you calculate 0.11 is your AS minimum, is less than 0 AS minimum, so we do not use 0.11, we have to use AS minimum. Okay, but if you calculate the spacing for AS minimum, okay, spacing is more than number 11 inch center to center. This is interesting. Okay, let me show you this calculation. For example, if I calculate AS, if I use, let's say, AS minimum. AS minimum is what? AS minimum is 0.119 square inches. Okay. Now I am using this value because my calculated AS is minimum than this one. Okay. So now once I calculate spacing for this steel area, that is area bar divided by AS minimum, that is 0.119 times 12. So let me calculate. My area bar is 4 divided by 9 equals, 4 divided by 9 equals square equals, that is 0.1975. Okay, divide by 0.119, give me, multiply by 12, it give me 20 inches roundabout, you can say 19.919 inches center to center spacing. Okay, and you see this is more than 11 inches, that is the maximum spacing, so we can't use this one, we have to use 11 inches. So if I using 11 inches center to center, then what will be my A is provided? Okay, again A is provided, so that's why I am calculating 0.1975, I think so, let me check it, 75 times 12 divided by 11. Okay, so this will give me A is provided, and that A is provided will be 0.22. Remember, this is the key concept behind 0.22, which I write here. Okay, so that's why if I am using 0.22, then my spacing will be number 4 at the rate of 11 center to center. Okay, because I can't use a 0.11, I have to use AS minimum. But if I use AS minimum, my spacing is more than 11 inches. So that's why I am bound here that I can't use spacing more than 11 inches. So if I use 11 inches bar, number 4 bar, 11 inches center to center, then what will be my A is provided? So my A is provided will then be 0.22, and then I come back here and check that A is provided is greater than S minimum but less than S max. So here I am okay as well. Similarly for this one as well. Okay. So these are the spacing, or you can say for my movement. Okay. Now do the same calculation for your panel B. Write down just only the movements. MA negative, MB negative in panel B, that is a square panel, both are same. Similarly, MA positive, MB positive are same. They calculated. Okay, just plug this movement right here in this formula. You got this AS, and AS will be 0.2. Clear? Similarly, you got this movement. Just plug this movement right here. You got the AS, and that is this one, but this is again less than, so this will be rejected, and you have to use as minimum. Do the same calculation. Okay, because 0.2 and 0.112 we can't use it because it gives us maximum spacing which is more than maximum spacing. So that's why we are bound here that we can't use spacing more than 11 inches. So that's why they are using the same calculation right here. Similarly for panel C, do the right calculation, same calculation. Clear? Now, this is very interesting that we have to place these bars. Okay, so placing is basically it is a very important calculation. Remember, most of the students do not know about the placing of these bars. So I will discuss this in lecture number 5 because they are a little bit tricky. I have to show you more further calculation because I have to show you what is edge strip and what is metal strip. Okay, so that will be also a new knowledge for you people. Okay, that what is metal strip and what is edge strip, because you are I hope you are listening this as a first time. Okay, so if you have any question, any suggestions, please share your suggestion, your questions, watch the video and enjoy. Thank you.